I'm Laura Barth, the Research Coordinator with the American Floral Endowment, or AFE. And on behalf of AFE, I would like to extend my gratitude for all of you coming out to our educational session on thrips and botrytis today. This educational session is part of AFE's Thrips and Botrytis campaign, which was started back in 2017 and has raised over $1.5 million US on research to combat thrips and botrytis in your operations. And so before we begin our program today, I want to direct you to this little card that you all should have. And if you don't have it, we have more up front. We can get you some. And if you scan this QR code, this will take you to a special informational page with all of our current thrips and botrytis information that you can use today in your own operations. We also have the program for today's informational session. You can find information about the speakers, about the presentations. There are one-page handouts with all kinds of information. Links to our webinars. There are special thrips and botrytis webinars that are in Spanish, as well as other information. And so we need to definitely thank our very generous sponsors whose support has allowed this research to happen and has allowed us to be here. Also, huge thank you to Ceniflores for just doing all the behind-the-scenes work to get this to happen. Anderson, Luis, Camila, everyone on Anderson's team for helping organize this, coordinating the venues, driving us. Muchas gracias. To GHT and Juan Carlos for their hospitality and showing our group the farms today so we could better understand Colombian horticulture and cut flower production. And also Juan Carlos for just being so instrumental in getting the thrips and botrytis program up and running. And even though we are in Rio Negro, I do want to thank again BOM, who sponsored our event in Bogota. So now I'd like to invite Juan Carlos up to say a few words.
Thank you. Good afternoon. It's a pleasure to be here. I want to give you a short presentation. Not all of you have seen the AFE. It's an institution that's independent that for 61 years has been working for floriculture. And it's extremely important that you know it and that you use it. It's been a permanent ally of production in Colombia. And we've had the honor of being able to have a member at the board of directors of Colombia, of which I was for 10 years, until this year that Jerónimo Herrera replaces from Jardines de los Andes. That position in the board of directors and the research committee could be transferring what really are our more urgent needs for research. The AFE is in charge of not just research, but also many internships and helps a lot of students with scholarships to promote floriculture in youth. And obviously, they have all that contact with the main universities that research horticulture. And during the years, we financed several projects, not just flowers, but also potted plants, which you can find on the webpage for AFE. And these are projects that are financed with that fund. 4 years ago, as Laura was talking about, this project started of thrips and botrytis that was born from the idea, since money is so limited and there are so many flowers and products, so we started to think, what could have a good or a great impact in our floriculture? And we reached the conclusion, very hand in hand with Terry Nell, who's in the back and is the director of research for AFE, and thrips and botrytis are permanent, that not just the floricultures, but everyone, florists, importers, etc., everybody's affected. And from here, It was born to actually create this special independent fund that this is separate to what AFE has. And these 24 sponsors were all these companies where you work, the majority of you. And we have Ceniflores is also there, obviously. And we were able to get this important money of $1.5 million to start the project. There's been several newsletters which have been handed out through mail and has also been helped to be distributed by Ceniflores and AFE to the sponsors. And listen, don't just leave it here in the direction where you use it of the manager, the owner, but really go to the technical area where it's necessary, so we can take advantage of all these interesting results that have occurred. Yesterday, what Laura was mentioning, in this QR code, you're going to find a lot of webinars in English and in Spanish, topics of thrips and botrytis, these last 4 years of results. Today, Dr. Ruz Bottenhouse and Jimmy House, with his team, Melissa Munoz, are going to show the advancements that we have to date. I think they're very big. Yesterday we saw it in the plains, and I really think there's a lot that we have to put in practice. And maybe emphasize that if these results and all these projects, that we hope this not be the last. I think it's the first, and many more are on the way, where all of the industry contributes, not just those who are associated to Ceniflores or independents, but the whole industry of floriculture, and that it reaches bottom and we implement it, so that at least that there's an extension towards the bottom in these presentations. And we hope it's very interactive. There'll be time for questions. It's very informal at the end. Feel at ease to ask in English or in Spanish. And the research are available to answer whatever doubts you may have, or leave doubts for the future, because they continue researching in the different topics that we have a need. So thank you very much for coming. I hand over the mic to Rose. Thank you very much.
Muchas gracias, Juan Carlos. Now I'd like to introduce Rose Boutenhouse, our first speaker. Dr. Rose Boutenhouse is Senior Research Scientist in Biological Control and Program Leader of the Biological Crop Protection Program at the Vineland Research and Innovation Center. She is responsible for the development and implementation of biological control technologies for management of arthropod pests, and is supporting sustainable crop management practices for ornamental horticulture. Welcome, Rose.
Thank you so much. My microphone is working, that's very good. So I'm very thrilled to be here. Everyone has been so welcoming, and I've been visiting some greenhouses with the group here, and I've been very impressed by the state of Colombian horticulture. I'm doing a lot of research on pests in ornamental greenhouses, and thrips are one of them. My career depends on thrips. Thrips keeps my family fed. But I understand, of course, thrips is a big, big problem. And in this presentation, I would just like to go over some thrips biology. Why is thrips a pest? And some solutions as well, hopefully. And as we go through the presentation, I will show you some of the results of the projects that were funded by the American Floral Endowment, so indirectly by you all. And hopefully there will be some lessons that you can take away from what I've learned doing my research in Canada and apply it here in the greenhouses in Canada and in Colombia. So I would like to have this a little bit interactive, so I hope everyone brought their cell phone. We're going to do some questions, just to get a feel for who you are, what your problems are, and what level of experience you have with integrated pest management. So if you go to www.menti.com, I hope you can see it, and use the code 48277625. And I'll put We can see the results live, so that's really the fun part of it. So the information now is on top. Menti.com. Oh, you already found it. This is great. So the first question is really, what is your role? Are you a grower, an advisor, consultant, a researcher, or maybe you have a different role? And we have 19 people now answering questions. Does anyone have trouble connecting? Is it okay? We're going to go back and forth a few times with questions like this, and the rest are just regular slides. Okay, so it looks like we have mostly growers in the audience, one consultant, some researchers, and then some people with different roles. So this is how it's going to work. Oh, one more other. Okay. You can continue contributing. I'll just go back to my slides. All right. So first I want to talk about thrips as a pest. As I said, in Canada we also have thrips as a pest, and we surveyed Canadian greenhouse growers in ornamentals and found that thrips are also #1 pest in greenhouse crops in Canada, especially western flower thrips. And it's the pest that caused the most losses. After that we have spider mites and some other mites, some aphids, whiteflies of course. But the reported losses due to thrips are between 5 to 10% of the crop. And I understand most of the time it's very similar here, although sometimes your losses can be very devastating. We also asked the growers, what is the most common pest? So it's a different way of looking at it, not only losses, but very common. And again, western flower thrips was the most common pest. About 2/3 of Canadian growers are happy with their integrated pest management program, and about 1/3 are not happy. So that's where I come in and do research to make, to develop methods to make them more happy. And then finally we asked what is the most difficult pest to control, and again thrips are #1, and after that some mites, aphids, etc. And the main reasons was that pesticides did not work for thrips. In Canada we presently have 0 pesticides that work for western flower thrips. Sometimes it works, but most of the time the thrips are resistant. So we have to do biological control. But sometimes biological control does not work, and we have a lot of problems with compatibility between pesticides for other pests and the biologicals for thrips. This is kind of a picture of where we are now. If you understand the pest better, if you know their biology, it is easier to devise ways to control the pests. So this is why I'm going to tell you a bit more about how thrips feed. This is actually a picture of a leaf, and they cut it this way. So you see the upper side and the underside of the leaf, and all the cells in between. What thrips do is they punch a hole in the cell, kind of mix up all the cell contents with their saliva, and then they suck the juices in to feed. And that leaves big holes in the cells, and the cells fill with air, and that's the silvery, whitish damage that you see on the leaves, thrips damage. Also, the thrips then have to digest, and they have to poop, and that's the dark spots that you see. That's thrips poop. Now so feeding damage is bad, but sometimes you can take off the leaves and no one knows. The big problem is the transmission of viruses. And we've heard a lot about virus transmission by thrips. The thrips larvae in the first and second stage of their development take up the virus into their body, And then when they're adults, they can transmit it to a different plant. The symptoms can be these rings or these spots. This is tomato spotted wilt virus. Here's a good example as well. And it's impatiens necrotic spot virus, which is the second most important virus that thrips can transmit. And if you there's no cure for viruses, so then you just have to throw the plants away before it spreads too far. And that's how you can have very devastating losses. Of course, you ship a lot of your flowers to other countries, so thrips are also a border issue. If thrips are found at the border, you'll have to do very costly remediation, or the shipment is refused, and that's not what we want, of course. So why are thrips so difficult to control? It's just a tiny little insect. Why is it so difficult? Well, first of all, thrips like to hide in the little spaces between the leaves and the stem, inside the florets in the flower. So they're very difficult to find, and they're very difficult to reach with a spray, if you need contact for a spray. Also, they lay their eggs in the leaf tissue, and the pupae are in the substrate. And again, that's very hard to reach them with a spray. They also can increase their populations very fast. One female can lay 7 eggs per day, and she lives for at least 1 month or more. So over the course of her life, she can have more than 200 offspring from one thrips female. So she can go from 1 thrips to about 6,000 thrips in 42 days from 1 thrips. They are also very good at dealing with plant defenses. They can detoxify plant defenses very good. That's why they have a very wide host range. They can attack over 500 plant species in more than 60 families, including a lot of crop species. So almost any plant can be a source or a refuge for thrips. The fact that they're so good at detoxifying means also that they're good at detoxifying pesticides. And at present, there's at least 175 cases of insecticide resistance documented, involving 8 different mode of action groups. So there's not a lot of products that they're not resistant to. A fun fact, I think it's fun, about thrips is that they have a very interesting reproduction. So the females have 2 sets of chromosomes, and the males only have 1 set of chromosomes. So the males, if they're exposed to a pesticide and they survive, all their genes go to the next generation. So the next generation will also all be pesticide resistant. A female also does not have to mate to reproduce. If she does not mate, she produces only males, but then she can mate with her own offspring, and the population can again go from 0 or 1 to 6,000 in a very short time. And thrips have a lot of help from humans. In the 70s and 80s, western flower thrips were a pest species or a species in California, western United States. But with worldwide trade, the insecticide-resistant strains of western flower thrips have spread all over the world. And I don't think there's a continent, maybe Antarctica, that doesn't have western flower thrips. And if there's someone on Antarctica that has a little plant, I can bet there's a thrips on it. So back to Canada. The province of Ontario is where I do my work. 15 years ago, the growers were spraying insecticides according to the calendar. Oh, it's Monday, I have to spray this. It is Tuesday, I have to spray this. So at least 3 times a week, they sprayed insecticides. Then resistance happened. So there was a big research effort on biocontrol for thrips because there were no more effective products for thrips. Now, about 94% of Ontario flower growers are using biocontrol as their first method of pest control. And sometimes they use a pesticide if there's a small problem. So 70% of the biological control budget is spent on thrips. It's a very, very important part of pest control. And because thrips can only be controlled biologically, you also need to control the other pests biologically because not many pesticides are truly compatible with the thrips biocontrol program. And here you see very happy growers, happy with their pest control program. So really, there's a shift from pesticide-based control to biological-based control. And biological-based IPM is a preventative, more long-term approach. You cannot wait until thrips are there and then spray. You have to assume or to know when thrips are a problem and preventatively put in place measures to deal with the thrips once they show up. More importantly, you have to understand why the thrips are a problem. Are there any underlying weaknesses in your production system that allow the thrips to be a pest? And then you have to address these weaknesses, which we call the systems approach. So it can be production, it can be environment, it can be a lot of different things. If you do not do that, and just go think biocontrol will save me, you will waste your money. You will spend a lot of money, but you will waste it because it will not work. You have to use all these different strategies, and that's why it's called integrated pest management. And this is my way of looking at integrated pest management. Those of you who are familiar with the disease triangle will recognize some of these elements. So in order to have effective thrips control, you need to grow the right plants. So plants that are resistant or tolerant to thrips. You can adjust your fertilizer or irrigation system to make the plant less susceptible to thrips. Then the other pillar of integrated pest management is to have the right environment. So starting with pest-free material, mass trapping, exclusion, biosecurity basically. Having the temperature and relative humidity and growing practices to make the environment as hostile to thrips and as friendly to plant growing as possible. And then if you have done all this, then you can start to think about biological control. And there's a lot of strategies using predators, parasitoids, not for thrips, there's no parasitoids for thrips. Microbes, biopesticides, and then as the last thing that you can reach to are pesticides. But hopefully by that time, you will not have used pesticides for a long time and the resistance may be less, so that the product will actually work. And in the rest of my presentation, I will go through these elements and I will show you different examples. But first, so that's how it works in Canada. But in the United States and here in Colombia, things are a bit different. For example, there's more pesticide options here, and some of them still seem to work. But resistance management is very, very important. You still have products that work, you have to maintain that situation because you don't want to lose these products. So that's why the systems approach emphasizes non-chemical tools as the first line of defense. And then keep pesticides for when they are really, really needed. All right, let's go to another question. I'm asking, how do you rate your experience level in integrated pest management? And we'll go to the next one. Are you a beginner? Is your experience moderately experienced? Do you have high experience? Or are you an expert? Can you do this in your sleep? Okay. We have some people with a lot of experience. No experts? I should vote. I'm an expert. Okay, moderate. The majority of you have moderate experiences. That's very good. Okay, thank you. Don't do this one yet. Don't do this one yet. So let's first talk about the plants themselves. The easiest thing you can do for thrips control is to choose varieties that are less susceptible. And there's variation between varieties. This is a graph from a study from Europe in chrysanthemums, and they tested how many thrips are on different varieties. And all these are different varieties. Here are the resistant varieties, and here is the number of thrips on susceptible varieties. The nice thing is that the resistant varieties were also more resistant against Liriomyza, the leaf miners, and spider mites. So there was some correlation, and that's this graph here, some correlation between thrips resistance and resistance against other pests. So if you can, grow the varieties that are more resistant. And now I would like to talk about the latest research that I've done with the funding from the American Floral Endowment. And it was all about fertilizer. We had the hypothesis that high levels of fertilizer make plants more nutritious, more delicious to thrips. And a lot of floriculture crops use a lot of fertilizer. There's room for decrease without effect on plant quality. And these are some studies here that show that that 50% reduction in these crops is actually possible. But our question was, are there additional benefits of lowering fertilizer levels for integrated pest management? And this is how I think it works. So this is a picture of a plant. You wouldn't say it, but here are the roots. Nitrate and ammonium are taken up by the roots and then transported through the phloem and the xylem of the plant to the leaves and the shoots, mainly as amino acids. And these amino acids are being fed on by pests like whiteflies and thrips. So also the proteins. Just like us, they need proteins to live. So reduced fertilizer likely lowers the plant nutritional value to pests. There's also some evidence that reduced fertilizer may increase the plant's natural defenses. In that way, it would slow down the increase, that graph I showed you, slow down, but it goes less fast, and hopefully give bottle control a better performance. So that was the theory. We did quite a few greenhouse experiments on different fertilizer levels. For example, this was 300 ppm of nitrogen, 200, 150, and 25 or 0. So you can see there is a big plant effect. There was an effect on thrips populations. You can see here from sticking the cuttings to flowering, the high fertilizer plants had more thrips than the low fertilizer plants. So there was some reduction. However, the rates that actually had an effect also produced less nice flowers. So that was a bit disappointing. But the biocontrol program that we tried at high and low fertilizer always worked well, so our biocontrol program was very good. So we went back to the lab to figure out what actually happens inside the plant. We grew plants, chrysanthemums at low and high fertilizer, and then we took leaves and put them in a cup together with thrips and counted how many eggs they actually laid in the leaf. These two graphs here show, so mostly look at these, that high fertilizer plants have more thrips eggs than low fertilizer plants. And again here you see high fertilizer and low fertilizer. There was also, we tried two different varieties, Byron and Grandview, and these are potted chrysanthemums. And you can see here, Byron had more thrips overall than Grandview. So there were varietal differences as well, but overall, the pattern stood. Then we also took leaf samples to analyze what is inside the plant. And we do this with a mass spectrophotometer. And it gives pictures like this. So the way you have to look at this is this analyzes all the metabolites in the plant and then groups similar treatments together. So the clustering here, you can see the clustering were very similar on the different varieties and not so much between high and low fertilizer. So the differences between varieties was much bigger than the difference between high and low fertilizer. If you zero in on one of these clusters, you do get that separation between low and high fertilizer. And most importantly, this takes into account all the metabolites in the plant. It could be proteins, defense chemicals, everything. If we take a closer look at what actually were the differences, we see that low fertilizer plants have lower concentrations of amino acids. So our theory was correct. There's less food for thrips. We also saw that low fertilizer plants had more defense chemicals. And there's one known defense chemical, chlorogenic acid, that the high fertilizer plants had always less defenses than the high fertilizer plants for all the different varieties that we tested. Also, when we had thrips feeding on the leaf, the plant reacted, the defense system of the plant reacted faster and more aggressively to thrips feeding. That you can see in here. Jasmonic acid is a part of the pathway that induces those defenses. So the low fertilizer plants had a better response than the low fertilizer plants. So overall, for thrips IPM, lowering fertilizer may reduce losses due to thrips, but we saw that the problem was that low fertilizer plants were not looking very nice. So we also saw that there were bigger differences between the different varieties or cultivars. So selection of the more resistant cultivars is important. If you grow susceptible varieties, then make those the focus of your pest management program. And then also, if you can lower some of your fertilizer, that will also give you cost savings because you lose less. At this point, do you have any questions? Or should I just continue? There's also at the end of the presentation, there will be time for questions. Any burning questions? Okay. So now on to the second factor, environmental, so biosecurity, mostly. We get our chrysanthemum cuttings from foreign countries. They're shipped into Canada from the propagator. And although the propagator has very strict phytosanitary measures, uses a lot of insecticides too, there are still some pests that come in on the cuttings. For western flower thrips, Pangliniella occidentalis, we found that almost all the samples were infected with 1 or 2 thrips per 20 cuttings. So that's quite a lot. Remember that graph? And it was mostly eggs and larvae, so they were very difficult to see. The eggs you cannot even really see in the leaf tissue. But all cultivars and all times of year there were these thrips on the cuttings. To our surprise, we also found spider mites. A bit more irregular, but a lot of spider mites also came in on the unrooted cuttings. So our growers already start with a disadvantage. They already have pests at the beginning of their cultivation. So one of the research projects that we did was immersing these unrooted cuttings in biorational products. The dipping or the immersion gives you 100% coverage all over the cutting. Because when you're spraying, most of the time, on the side of the leaf. So we use biopesticides or reduced risk products like mineral oil, insecticidal soap, or Beauveria bassiana. Because these products give less potential for resistance. They also leave minimal residues, so after you use it, the biocontrol agents are not negatively affected, and they're highly compatible with biocontrol agents. And here's, you can see how we do the dips. So we receive the cuttings in the bags, then they're put in a tray with holes, kind of loosely in the tray, and dipped into the solution. Oh, it changed by itself, look at that. So these are the results of all the tests that we did. On the left, you see the products and product combinations that we tried. Copa is insecticidal soap, Botanigard is Beauveria bassiana, soft oil is oil, and landscape oil is another oil. Overall, we could see that the spray rates sometimes are phytotoxic to cuttings. So you have to lower the rates, but the low rates were still effective. On hardy crops, like mandevilla, chrysanthemum, they could support quite good high rates of products. But we got the best results with oil products and Beauveria bassiana. For Bemisia, it's Bemisia, whitefly, thrips, and 2 spotted spider mites, Tetranicus. So for thrips, the oils and the Botanigard did the best job. On the more soft crops or sensitive crops like poinsettia, mini rose, the really tiny potted roses, we had to really go at low rates. Some of them were phytotoxic, but we still found combinations that would work. So you disinfect the cuttings at the beginning when you receive them, but then you still have to do the rest of the cultivation. There still may be problems. So this is a graph where we try to see what happens if you dip and then do biocontrol, compared to doing only biocontrol or doing nothing. So the blue line, this line, is when you do nothing. And you can see over 2 to 4 weeks, the thrips population goes up. This is the treatment with biocontrol. So biocontrol alone reduced the number of thrips, which is okay, but still thrips increased. If you dip, you reset the clock on the thrips. And if you only dip and then do nothing, the thrips start to increase again, and probably this will go up again like this. If you combine dips and biological control, you keep the thrips low and give the biological agents time to start working. Over the course of the growing season, of course, we also have thrips coming in from outside. And that's what this slide is all about. Over the summer months, from June to October, we found thrips outside and inside the greenhouse, and the populations were correlated. This is western flower thrips, so you can see when there's outside thrips, there's also inside thrips. This is a different species, onion thrips, also called thrips tabasi. We also have them outside, and then they go into the greenhouse. Now, one of our problems with onion thrips is that the biological control programs do not work as well against this species of thrips. So you can see that the onion thrips throughout the winter stayed in the greenhouse at higher levels. But this tells us that a lot of our thrips are coming in from outside. So screening would be a very good option to keep those thrips out. Now you have to choose a screen that has very, very small holes that the thrips cannot go through. The problem is that it also restricts airflow, and as all growers tell me, the climate inside the greenhouse is negatively affected. It gets too hot and too humid if you screen all the vents. I would say we have to look at this. Maybe there are screens or structures that we can do that will keep out the thrips, but will less affect the climate inside your greenhouse. This would be a very big win for the industry, because if we can exclude the thrips that come in, that would help tremendously. Also, biosecurity is maintaining a good protocol, so going from the clean crops to the dirty crops, not the opposite. Don't carry thrips from the dirty plants into your mother plants or the cuttings that you just stuck. You people are very, very fond of mass trapping. All the big sticky tape, the different colors, it's very interesting to see. The color could make a difference, but I think it is very situation specific. In Ontario, my colleague Sarah Dendresic found that yellow actually worked better than blue for thrips. This might not be the case here in Colombia or in different areas. You just have to do your own trials to see what color works the best. So don't take this as like the truth. It may be different here. But overall, place the sticky traps just above the crop, because that's where the thrips are moving. Also place them at places where the thrips come in. So before they get to the crop, they will get trapped away. And there's some promising research with lures, thrips lures, the plant pheromones, that can increase these thrips captures on sticky traps. So again, to summarize the early intervention points related to the environmental factors, dipping cuttings is for our growers, it's a no-brainer. About all the growers dip their cuttings to knock down those pest populations from here to here. so that the increase will go slower. And the biocontrol agents will start working. Then, over the course of the production time, exclude the pests for screening and biosecurity. Grow resistant plants, again you lower the thrips increase. And use biocontrol. At least that's what our growers do. To manage those residual populations and to continue having low populations of thrips. Okay, let's do another quiz. So we'll go to Menti again, and the question now is, are you using biological control? No, sometimes, often, or always. So in my case, as a researcher, I always use biological control. Okay, sometimes. I'm going to take a bet that this is for spider mites. Yeah? Okay, often and always. Very good.
Rose,
Oh,
a question on the digging. You meant?
do we need a microphone?
Yes, please. Thank you. Yeah, you mentioned a little bit this morning on that. So I wonder if you can elaborate a bit more. When we did the cuttings with biocontrol agents, the residuality of the insecticides we used in the mother plants may affect them for a long term, probably, and the dipping would not be that effective because of that residuality. Can you elaborate a bit more?
Yeah, the residues you use in propagation. Your question is if they affect the biological control agents we use for dipping. So for dipping, the oil and the soap is not affected. The Bovaria, if you use a lot of fungicides and there's a lot of fungicidal residues, maybe. But overall, I think the type of products that are used for dipping are not affected by pesticide residues. Actually, some products with a high pH, someone told me that a high pH can wash off some of the pesticide residues. I don't know if it's true. I'm trying to find a scientific proof for this, but that's what someone told me. Would you like me to put that down again? All right. Oh, you have another question? No? Okay. All right, so we have people who sometimes use biological control. Very good. Next question is, if you answered no, I'm not using biological control, I would like to know why not. And there's several reasons, and you can rank them on your quiz there. So, are they incompatible with insecticides? The insecticides you use will kill the bios. You don't know how to use biological control. The growing area is open to the outside, which is the case here, of course, and maybe you're concerned that the biocontrol won't work because the pests just keep coming in. Maybe you have very low pest pressure. You don't need bios. Too expensive, not effective, difficult to implement. So what's the reason why not? Okay. Yeah, it is difficult to implement, I agree. The other two reasons are very good reasons, and we'll come back to those reasons as well. Oh, low pest pressure. Who has no pests? Okay, I see some responses are still coming in, so. Okay. Okay. Good, let's go to the next question. My next question, if you answer yes, I am using biological control, I would like to know the main reasons why you are using biological control. So, first reason, and that's very important in Canada, as I told you, pesticide resistance was the main reason why growers switched to biological control. The second reason here, I say no re-entry or pre-harvest interval. This is when you spray and you have to close the greenhouse and stop harvesting for a certain period of time with pesticides. Worker health and safety, better plant health. Some sprays tend to be phytotoxic. No pesticides available, so you have to use biological control. Consumer demand, your customers want you to use biological control. What else? Or less expensive. Biocontrol is less expensive, could be another reason. So let's see how you rank all these. Oh, pollinator health, yes, I did mention that. Okay, so it looks like it's not really a problem that you have to close down the greenhouse after you spray. And that the main reason that you want to use biological control is pesticide resistance. Just like Canada. Okay. I think, yes. Here I would like to ask you, what biological control agents do you use? So you can just type in the name of the product or the organism or the type of material, and we'll get a cloud of words that is going to show up on the screen. So just type whatever you want, and we will have all those things appearing on the screen. It could be the trade name, it could be the species name. Tigerfly. Yes, I love tigerflies. Okay, some mites, Bacillus subtilis, Bacillus pumilus, some of the biopesticides, the Metarhizium, Bovaria. So of course those are fungi. Plant extracts, Stagiolyphus for leaf miners, Trichoderma in the soil. And the bigger the word, the more of you will have typed the same name. Steinonema, so we have nematodes. Nematodes also on the far side there. Oh, Bacillomyces, nice. Okay, that's a good overview of the products that are available. Tigerfly, of course, comes in from outside. And a lot of fungi and beneficial microbes. Okay. Can we go to the next one, or are you still typing? Oh, don't do this one yet. We'll go back to the presentation. Okay, so this, before I came here, I asked around and asked what products are actually available in Colombia. So with the information that you just gave me, I will be able to update this slide. But what I understood was that commercially, you can buy the 2 predatory mice that will control spider mites, Phytocilus persimilis and Neosilus californicus. You have Bovaria bassiana, but now I know you also have other fungi. And then reduced risk pesticides, you have a mineral oil product, and then the plant extracts, and all those products will also fall under those. Yeah. So let's talk a little bit about entomopathogenic fungi and how to use them. So entomopathogenic fungi like Beauveria, Metarrhizium, they can be used preventatively. So you spray them, and when thrips come in, they will come into contact with the residues. Or curative, when you see thrips, you hit them with the spray. But what's very important is that you get the spores of the fungus everywhere where the pest is, because it only works on contact. So good coverage is essential. So most of the time with low volume, kind of a very fine mist is the best to get it all around the plant. And you don't want it dripping off the plant too much. That product will mostly do in a fine mist. If you have access to the equipment, there are these cold foggers. They're kind of like cannons that produce a very fine mist. You can use cold fogging for entomopathogenic fungi, but there's other equipment that are based on heat, generating a mist with heat, but that will kill the spores of the fungus. So don't use the ones that generate heat. There's also some granular formulations that you can mix into the substrate against the thrips pupae. Now, commercially, you don't have a lot of biocontrol agents available for thrips, but you do have, Anderson tells me, Colombia is known for its biodiversity. So there must be biological control agents outside that can come in naturally inside the greenhouse, or that you can collect and use as biological control agents. And Cenosia, the tiger fly, is a good example. That's one that you just get for free from outside. I think you also have Aureus insidiosus. I've been trying to find them during my days here in the flowers outside, but I haven't found one yet. You have predatory mites of the families Phytoseidae or Lelapidae that are very good thrips predators either on the leaves or in the soil. But again, not commercially available. And there's probably a lot of generalist predators like lacewings, syrphid flies, those little flies that mimic bees, or lady beetles. So there must be quite a few biological control agents that you can naturally get. And this was me 5 years ago at my visit, and I found one flower around the greenhouse, and I was hoping to find Aureus, and I was tapping it, and I found just a lot of thrips. So if there are some native predators, there are some methods that you can use to rear them yourself. On the left, there's a method to rear Aureus insidiosus. They can feed on moth eggs, and they can lay their eggs in green plant material, and that way you can rear thousands of them and release them in the greenhouse yourself. The same can be done for predatory mites. Predatory mites do very well on mold mites. Those are the little mites that you can find that feed on mold. And you can just put them together with bran and a few other things and rear masses of cucumbers, for example, or Swirsky, if you can find it. Now the last option is to attract the beneficial insects with habitat plants. This is a social media post from one of my good friends, Ronald Valentin. He is an advisor in Canada and in the United States, and he works with Metrolina, which is a big greenhouse in the United States. And all these plants that you see are grown to promote and to harbor beneficial insects. So here you see alyssum, which will attract syrphid flies. It will feed Aureus. Here you see ornamental peppers, again for Aureus. And then there are some mullen or verbascum plants that will also promote and feed mirrored bugs that are very good predators of many different bugs. So that's all I can tell you now about biological control. I hope soon you will have more products available so that we can play a bit more with the biological control strategies. But for now, you have to control thrips still with a lot of insecticides. And in the next few slides, I will hope to tell you a bit more about how to best use the insecticides to prevent resistance from developing. So insecticides, and these are slides from another researcher at Clemson University, Jason Chong. I borrowed these slides from him because I am not a pesticide expert. So if you would ask me, what group is this pesticide, I would have to look it up. So I apologize about that. But insecticides can be systemic, so you can apply them on any part of the plant and they will move through the plant. So you will often apply them as a drench and then they will move throughout the whole plant. But when drenched, when they are applied to the root, they will not protect the flowers. Very important. Translaminar insecticides you spray and they will enter the plant at the place where they land. But they are not moving throughout the whole plant. They just stay localized in the tissues. And then finally, contact insecticides have to be in contact directly with the pest in order to kill. Okay. Now, of course, the whole theme of this presentation is that Western flower thrips are known to develop resistance very quickly. So what should you do to delay or to mitigate the insecticide resistance is to try to reduce your use of insecticides as much as possible. And also very important is to rotate the insecticides among the different modes of action or insecticide resistant action, IRAC, group numbers. You can find these group numbers on the pesticide label, and there are also websites that you can look up the active ingredient and know what kind of group it can be. So for example, neonicotinoids, pyrethroids, those are all different mode of action groups. And then of course combine cultural, biological, and then chemical control measures so that you have the basis of physical and cultural control, and then use the pesticides as a last resort. So how do you rotate insecticides? It's actually quite simple. You want to look at that IRAC number, or the mode of action, and then you rotate. You just use a different number every, if you spray weekly, rotate to a different number after 2 sprays. By that time, the thrips will be exposed and the resistant ones will survive. So then you want to use something else that will actually kill them. That's the whole principle, right? So an example here is a 4A group, a 5, and a 6. So those are all different numbers. You do not want to look at the numbers here. So 4A and 4D, that's not a good rotation. You will get some of that cross-resistance. And then finally, like I said, foliar sprays are needed to protect the flowers because systemic insecticides will not move to the flowers from the roots. So also the flower will open gradually. And because you need to use a contact pesticide, you have to get the spray actually in the flower. Also, the residual efficacy of insecticides against thrips is not often very good, so you don't get a very long period of protection out of it. So repeated spray applications are needed to protect the flowers. Okay. Now, more important, and if there's anything that you take away from this presentation, it's how to integrate, how to use insecticides and biological control agents together. So it's not easy, it's really, really difficult to do it well. So you have to have quite a bit of knowledge. First of all, if you are moving from a heavy spray program to biological control, often the residues of those years of pesticide use will be on the structure and on the crop, and that may interfere with the biocontrol program. So also, if you are using pesticides that can control a lot of different pests, if you stop using them, there may be outbreaks of secondary pests that you didn't even know you had them, because the broad spectrum pesticides were keeping them under control. But judicious use of pesticides can actually, for example, get the population of thrips down so that you can actually use biocontrol more easy. You can also use pesticides to clean up at the end, just before you sell, or to use it as a spot spray. And the most important tool is the side effect database. So the big companies like Cobbert, BioBest, they all have this on their website. You look at side effect database, and this one is from Cobbert. It tells you the different insecticides on the top and different biological control agents on this side, and it forms a matrix. So for example, here we have an aphid parasitoid, Californicus, Aureus insidiosus, which is the predatory bug, and Phytocetus persillus. Just as an example, you can put in whatever you want. It will tell you what the effect of the pesticide is on the pest, and low numbers in green are compatible, high numbers in red are not compatible. It also tells you the persistence. How long will this pesticide have an effect on your biocontrol agents? And it can go from 1 week to 8 to 12 weeks. So in the next few slides, we're going to look at elements of this table. Oh, before we do that, also check your fungicides. It's not only insecticides or caricides, the products against mites, that will cause you problems. So here's the first column. I just picked a random insecticide that's available here. You can see they're all green number 1. So that means that less than 25% of the biocontrol agents died when they were exposed to this pesticide. What's also very nice is that there is no residual effect of this pesticide. So after 0 weeks, the biocontrol agents will still be alive. However, there's also places where there's no data. We just don't know what effect it has. So don't assume that if there's ones here, that this organism will also be fine. And the last thing about compatibility, this table will only tell you what percentage will die. It doesn't tell you if the biocontrol agents are still in good shape to predate, to lay eggs. The pesticides may have some effects on those, and we call them sublethal effects. But there's no information on that. Here's an example with a lot of 4s. So a red 4 means that more than 75% of the biocontrol agents died. However, these two products are different in that the first product, abamectin, has a 1-week persistence, while the second product, bifenthrin, has 8 to 12 weeks residual effect. So, if possible, if you want to use bios and maybe one of these products, choose the product with the shortest residual, so that at least 1 week after you know that the bios will not die from the residues. So overall, these two products are not compatible, but if the residual time is short, you can reintroduce the bios after you spray, after the residues have gone away. Or you can use it as a spot spray for hot spots, just at the places where the pests are, or as a cleanup spray at the end of the production cycle. And finally, I have an example here where the method of application is very important. This is the same product, imidacloprid, it's a neonicotinoid. If you spray it, you see all these red 4s and orange 3s, so it's not compatible as a spray. However, if you drench it, apply it to the roots, it is compatible with most of the biocontrol agents, but not with all. For example, Aureus insidiosus tends to take a little water from leaf tissues. It doesn't cause damage, but that way it ingests the systemic insecticide and will die. So again, switching to biocontrol is not easy. And you have to be very knowledgeable and careful combining biocontrol and insecticides. It is possible, but think about the residual time and the compatibility. But if it works, a biocontrol-based IPM program is sustainable, safe, and very resilient. It will not fail easy once you find what works for you. And here I summarize this in, this is an example of growers in Ontario, what they do. This infographic shows potted chrysanthemums from unrooted cuttings to when the crop flowers and is sold. So when the cuttings are received, we dip to make sure that the cuttings are clean, and we start clean. We also already start our biocontrol program with predatory mites such as cucumeris or Swirskii. When the cuttings are transplanted, more predatory mites, we use biopesticides and some of the soil predators. And a lot of our growers also use nematodes. And then once the canopy closes, the nematodes are stopped because it's very hard to get them inside the soil, where the thrips pupae are. Oh, I have a pointer. Look at that. I like to kind of like. Once the chrysanthemums go into short days and they're spaced out a little bit more, more predatory mites in the form of these breeding sachets, more predators, more biopesticides. Over the course, of course, all mass trapping. We like the yellow sticky tape. And then, if needed, if there's still thrips when there's just before they're sold, then growers can use a pesticide. And because the rest of the program has been biological, there's some chance, or a good chance, that the pesticide will actually still work, because the thrips have not been exposed to these products before. So I can actually change my slides myself now. There we go. And last but not least, all my research has been mostly on Western flower thrips, Frankliniella occidentalis. But a few years ago, we discovered that we have more thrip species that we have to be concerned about. I already mentioned the onion thrips, Thrips tabasi, which is now a problem because our biocontrol programs work less well. We think it has something to do with behavior, that the behavior of the Western flower thrips and the onion thrips are different. But I have a master's student now from Colombia who is going to work on that. So it's important to start to know what thrip species you have in your greenhouse. For our growers in Canada, we made a simple identification key. Here's the link. I don't know how useful it will be for here in Colombia. You have different thrip species. You have Frankliniella panamensis and a few others. But I just want to let you know that it's important to know what thrip species you have, because sometimes the treatment will be different. So I talked about a lot of different strategies. I would like you to tell me what other strategies, is there anything that I did not talk about that you are using to control thrips? And some of you have already started. Today we saw the vacuum cleaner. That was so much fun, I'm very excited about that. chemical control, of course, and we talked a little bit about traps. You use a lot of traps. Anything else, maybe? I don't know. HPR. I don't know what that is. No one wants to tell me? Oh, solarization. Yeah. So that's, again, it's biosecurity, right? So starting clean. Biological control, yeah. Host plant resistance, thank you. Repellents, yes, we didn't talk about repellents. Yeah, pheromones, the lures. Basically, that's it. Oh, drench, sure. All right. I think this is my last question. So I've been talking for 1.5 hours. I hope I told a few new things. Maybe a lot of it you already knew, but you learned today that you're going to try. And this again is a free form. And this will tell me if I've done a good job as a presenter to bring something new to you. Cutting tips, nice. If you need more information on anything of this, if you need more information, just let me know if you need help or any more information. And before we go to the questions, do we have an extra translator thing for me? Oh, we have one here. Okay. Because I'm sorry, my Spanish is very bad. Muy bad. Malo. Okay, compatibility tests. You can keep doing this. I will leave it up. I'll just want to go to my thank you slides here. Thank you very much for listening to me for so long. I hope you liked the format, the questions. I really appreciate you answering those questions. And I will have access to that to see how we can make biological control work in Colombia. Of course, thank the American Floral Endowment and all the sponsors of the Thrips and Botrytis funding. And here's my email address. Don't write to me in Spanish, or maybe I can put it through Google Translate or ask someone. But anyway, if you have any questions that you didn't get answered in this question period, then you can always email me. So thank you very much. So we're going to try questions. And we have a microphone, I think. Oh. Oh, right here. Over here.
Hi, Doctor. Good afternoon. Doctor, I have a question. Do you and your team and you maybe try with metarhizium strains, specifically metarhizium brunneus strain, and controlling thrips into the soil, into the leaves? Thank you.
Yes. So I haven't shown many of the results, and I haven't shown much of the results for metarhizium. We had a product available in Canada that was based on the strain F52, Metarhizium brunneum F52. And that was very effective for control of thrips. We could use it as a spray or integrate it in the soil against the thrips pupae. Yes. For a while that product went off the market, but I'm very happy that it's coming back. different supplier, but we have the product again. It will also help much against spider mites and aphids, this strain. So,
It's a long range of control.
for
For a long range of control.
the long,
Long range.
yes, a big range of control indeed. So there are different metarhizium products and different strains, so they don't all do the same thing. The other thing that we've done research on is the compatibility of metarhizium with a lot of other biological control agents, and I know Anderson is also working on that. So I can, if you are interested, I can share some of the research papers for that.
Yes, I am. Thanks.
Yeah.
Thank you.
Yeah, it's
Thank you
working.
very much. My question is about mixing ectomopathogenic fungus, for example, Barbaria and Metarhizium and Isaria. What is the conclusion about that? And second one is about mixing this kind of entomopathogenic with predatory mites in leaf.
Yeah, so mixing the different fungal products together, I actually don't know what will happen. I'm assuming that it will be compatible, but I'm not sure. It's a very good question. Now, if you want to use these fungi together with biological control agents, there will be some mortality with certain biocontrol agents. I know that the Heteroptera predators are very susceptible to Bavaria, for example. Others, like predatory mites, are not very susceptible. And actually, there's some research out of Montreal in Canada, the University of Montreal, where the predatory mites are dusted with Bavaria spores, and they carry the spores over the crop to the places where the fruits are. So they're used to carry the spores, which is indicative that it's very compatible. Any other questions? Everyone's asleep. No? Okay, I'll be around here for after the next presentation as well. Thank you so much for coming, even with the truckers all blocking the road and everything. Thank you for your hospitality, and hopefully we'll see each other soon again.